Bismillahirrahmanirrahim. For the S domain circuit in figure 1, find part A, the transfer function h of s is equal to v0 over vi. v0, this is v0, this is vi. Part B, the impulse response. Part C, the response when vi of t is equal to u of t volts. And part D, when the response when vi of t is equal to 8 cos 2t. So we first need to find the transfer function and the impulse response. Then for two inputs, one is u of t and the second is 8 cos 2 of t, the sinusoidal input and the step input, we need to find out the response of the circuit for both the cases. So we can proceed to find out the transfer function in many ways. So for example, we can apply the mesh analysis, or we can apply the node analysis, or we can just find the equivalent impedance across this branch, and then use the voltage divider to find v0 over vi, the transfer function. So let's apply node analysis. Let's assume this voltage v here is v1 here, right? v1, or to avoid ambiguity with vi, let's say this is va, and this is our reference node. So using node analysis, so this is va minus vi divided by 1, right, plus va divided by 1 for this branch, and for this branch va divided by s plus 1. So s plus 1 is equal to 0. So the sum of all the currents leaving this node is 0. va minus vi divided by 1 plus va divided by 1 plus va over s plus 1 is equal to 0. So let us multiply throughout with s plus 1. So this is or let us simply separate the terms relating to va. So this is va, so this is 1 over 1, this is 1 plus 1 plus 1 over s plus 1, right? And this is equal to, this is minus vi over 1, so this is equal to vi. So this is va into 2 plus 1 over s plus 1 is equal to vi. So this is va, this is s plus 1, so this is 2 into s plus 1, and this is plus 1 is equal to vi. So that is va is 2s, and the 2s plus 2 plus 1, that is 3 divided by s plus 1 is equal to vi, right? So va is equal to s plus 1 divided by 2s plus 3 vi. So let's call this equation number 1. Now let's apply the voltage divider rule here. So v0 is equal to 1 divided by the total impedance of this branch is s plus 1 multiplied by va, right? So the total voltage across this branch is va, and by using voltage divider rule we get 1 divided by s plus 1 into va, and this should be equal to this voltage v0. So v0 is equal to 1 over s plus 1 into va. We substitute this value here. So this is s plus 1 divided by 2s plus 3. So v0 is equal to, this cancels out, 1 over 2s plus 3, and va is also in terms of vi, right? So we needed to write vi here, and we needed to write vi here. So the transfer function v naught over vi is equal to 1 over 2s plus 3. So h of s is equal to v naught over vi is equal to 1 over 2s plus 3. So this is the transfer function for this circuit. We have completed our part A, right? Now part B is the impulse response. So the impulse response h of t is equal to inverse Laplace transform of h of s, right? So h of s, it can be written as 1 over 2 into s plus 3 over 2. We take the 2 common. So h of t is equal to 1 over 2 e raised power minus 3 over 2 t u of t, right? So this is the impulse response of the circuit, right? So this completes our part B. So now we need to find out the response when vi of t is equal to u of t. So we either convolve this, right, u of t with h of t to find the response v naught t in the time domain, or we use the transfer function in the frequency domain to find out the response, right? So part C, the input is vi of t is u of t volts. So v1s in this case is 1 over s, right? The Laplace transform of u of t is 1 over s. So now h of s is equal to v naught over vi, right? And this is equal to 1 over 2s plus 3. So v naught is equal to h of s multiplied by vi of s. So vi of s is given and h of s is given, so we can find out v naught of s is equal to 1 over 2s plus 3 multiplied by 1 over s. So v naught is equal to 1 over s into 2s plus 3, or we can write it, we can take the 2 common, 1 over 2s into s plus 3 over 2, right? So we can write it in that form also. So we need to now expand this using partial fractions to find out the inverse Laplace transform. So let v naught is equal to 1 over 2s into s plus 3 over 2 is equal to a over s plus b over s plus 3 over 2, right? So now we let s is equal to 0. So we multiply with throughout first with s is equal to 0, right? Sorry, we multiply throughout with s is equal with s. So this becomes s v naught is equal to 1 over 2 into s plus 3 over 2, and that is equal to a over s multiplied by s is a, and this is b s over s plus 3 over 2, and now we let s is equal to 0. So let s is equal to 0. When we let s is equal to 0, so then this term becomes 0, this disappears, and a is equal to this term with s substituted equal to 0. So a is equal to, we write a is equal to this s v naught when s is equal to 0. So this is 1 over 2 into, So we put s is equal to 0, so that is left with 3 over 2. So we have a is equal to we have substituted s is equal to 0 here, so this is the 2 cancels with 2, this is 1 over 3. So a is equal to 1 over 3, right? Then we multiply this with s plus 3 over 2, right? Let's call this this was our equation 1 here, and let's call this equation 2 here. So let us multiply 2 by s plus 3 over 2, right? So this becomes s plus 3 over 2 v naught is equal to, so when we multiply this with s plus 3 over 2, this leaves with 1 over 2s, right? And this is equal to, so a is multiplied by s plus 3 over 2 over s a, and this is left with b only. So when we put now s plus 3 over 2 is equal to 0, that is s is equal to minus 3 over 2, then this term disappears because s plus 3 over 2 is equal to 0. This a term disappears, we are left with b only. So in that case b is equal to 1 over 2 and s is equal to minus 3 over 2, so that is minus 2 over 3. So this cancels out, so b is equal to minus 1 over 3. So a is equal to 1 over 3, b is equal to minus 1 over 3. So this leaves us, we substitute a and b here now here, so v naught of s is equal to 1 over 3 over s plus 1 over, sorry, minus, this is minus, right? Minus 1 over 3, b is minus 1 over 3, s plus 3 over 2. So v naught t in that case, 1 over s is Laplace transform of u of t. So this is 1 over 3 u of t, and this is minus 1 over 3 e raised power minus 3 over 2t u of t. So v naught t is equal to 1 over 3 into 1 minus e raised power minus 3 over 2t u of t. So this is the response of the circuit when for the step input u of t. So we didn't need to solve the entire circuit. We just knew the Laplace transform and we knew the input, and we multiplied them in the frequency domain and then found out the response in the frequency domain, and then using the inverse Laplace transform we found out the response in the time domain. So this was part C, and now we have part D, when vi of t is equal to 8 cos 2t. Part D, we have in this part C was u of t, and this is now sinusoidal input. Vi of t is equal to 8 cos 2t. 8 cos 2t volts, right? And the Laplace transform of this sinusoidal function is vi of s is equal to 8s over s square plus omega square. Omega is 2 here, this is 4. 8s over s square plus 4. So now h of s is equal to v naught over vi, and this is equal to 1 over 2s plus 3, right? And so v naught is equal to h of s multiplied by vi of s. So v naught in this case is 1 over 2s plus 3 multiplied by 8s divided by s square plus 4. So we can take 2 common here. So this is v naught. This is let's say 1 over this 2s plus 3 over 2 into 8s over s square plus 4, right? So this will be v naught is equal to, so this is 4s divided by s plus 3 over 2 into s square plus 4. So let us have a look again. So we are given vi of t is equal to 8 cos 2t volts. So the Laplace transform for this is for cos omega t, the Laplace transform is s over s square plus 4. So this is 8 multiplied by s divided by s square plus 4, right? Omega is 2 here, and then h of s is equal to 1 over 2s plus 3, right? So v naught is equal to hs multiplied by vi. So h of s is equal to 1 over 2s plus 3 multiplied by this input 8s into s square plus 4. We multiplied the transfer function with the input in the frequency domain to find out the response in the frequency domain. So this is 1 over 2 is common, s plus 3 over 2. So this is 8s over s square plus 4. So 2 divides here, we get 4s divided by s plus 3 over 2 and into s square plus 4. So this is the function that we have got response in the frequency domain. We now need to find out its inverse Laplace transform. So for the inverse Laplace transform, we need to expand it using partial fractions. So let me write down the function here again. V naught is equal to 4s divided by, this is the response, right? 4s over s plus 3 over 2 into s square plus 4, right? And let it be equal to v naught be equal to, this is simple term a over s plus 3 over 2. This term involves complex conjugate pair of poles, right? So we need to write it like this: bs plus c over s square plus 4. So let me call this this was our equation 2 here, and let me call them equation 3 and 4. So 3, 4. So to find a, we simply multiply v naught with s plus 3 over 2 and then substitute s is equal s plus 3 over 2 is equal to 0. So multiply throughout with s plus 3 over 2. So s plus 3 over 2 v naught, this results in this expression 4s over s square plus 4, right? And here this results in a plus bs plus c over s square plus 4 multiplied by s plus 3 over 2, right? So now let s plus 3 over 2 is equal to 0, that is s is equal to minus 3 over 2. So in that case this will become 0 and we are left with a. So a is equal to this here substituted with s is equal to minus 3 over 2. So a is equal to s plus 3 over 2 multiplied by v naught substituted s is equal to minus 3 over 2, and that is equal to 4 into minus 3 over 2 divided by s square is 9 over 4, right? 9 over 4 plus 4. So A is equal to this is minus 6, right? Minus 6, and this is 25 over 4, right? 25 over 4. So this is equal to minus 24 over 25. So A is equal to minus 24 over 25, right? Now we let S is equal to 0 here in this equation, right? Let S is equal to 0 in 4. So and if we let S is equal to 0, this will render this term equal to B term equal to 0, and we're left with C, right? And then we can evaluate the coefficient C by substituting S is equal to 0 here, right? This is S is equal to 0. This will result in this being rendered 0, this term being rendered 0, this term being rendered 0, right? And this term also will be rendered 0 on this side when we put S is equal to 0 here. So S is equal to 0 may not work. If we put S is equal to 0, this will not work. So let us put S is equal to 1 instead. S is equal to 1 in 4. So this will yield one equation, and then we put S is equal to, this will yield another equation. We can solve them simultaneously to find the values of B and C. So let's put S is equal to 1 in 3 and 4. 3 and 4. 4 and 3. So S is equal to 1 yields 4 divided by, so this is 3 over 2 plus S is equal to 1, that is 2 over 2, that is 5 over 2, and that is S is equal to 1, this is 5, and that is equal to A over S is equal to 1 here. So this is again 5 over 2, right? And this is B plus C divided by 5. So we have this is 8 over 25. This is 25 over 2, and 2 goes to the numerator here. This is 8 over 25, and that is 2A over 5, and that is B plus C over 5. So we can multiply throughout by 25. So this is 8 is equal to, so this is 10A plus 5 into B plus C. So that is our equation number 5, suppose. And then we let S is equal to 2 in 3 and 4. So S is equal to 2, so that is 8 divided by, so S is equal to 2, so that is S is equal to 2, so 2 plus 3 over 2, so 2 is 4 over 2 plus 3 over 2, that is 7 over 2, and this is 4 plus 4, and this is 8, and that is equal to A. We do not substitute the value of A yet, huh? We will substitute the value of A afterwards. So A over this is again S is equal to 2, so that is 4 over 2, that is 7 over 2 plus 2b plus c divided by, so this is 4 plus 4, that is 8, right? So this is 8 over, so sorry, 8 cancels with this 8, right? And we are left with 2 over 7, 2 over 7. So this 2 goes to the numerator and 2 over 7, and that is 2 over 7a, and we have plus 2b plus c over 8 here, right? And we can now substitute the value of a in both these and then solve them simultaneously together to find out the value for b and c. So substituting 24 over 5, minus 24 over 25 for a in this equation and this equation, and then finding out the value of b and c. So from 5, so 8 is equal to 10 into 10 into minus 24 over 25 plus 5 into b plus c, right? So this is 5 into 2, 10, we are left with 5, so 8 is equal to minus 24, 24 into 2 over 5 plus 5 into b plus c. So we have 5 into b plus c is equal to 8 plus 48 over 5. So 5 into b plus c is equal to, so this is let me say 48 is basically 40 over 5, and this is 48, so this is 88 over 5, right? 88 over 5. 8 into 5, 40 over 5, that will give us 8, right? 88 over 5. So let us see if we can arrive at a simpler expression for 6 also, then we can solve them simultaneously together. So let's substitute the value of a here also. So this is 2 over 7 is equal to 2 over 7 into minus 24 over 25, right, plus 2b plus c over 8. So this seems a bit complicated, right? So we can write it 2b plus c over 8 is equal to 2 over 7 and plus 2 over 7 into 24 over 25, right? So 2b plus c is on one side and we take on to the other side 2 plus 7, 2 over 7 plus 2 over 7 over 24 over 25. So 2b plus c over 8, we take 2 over 7 as common, so write 1 plus 24 over 25. So 2b plus c over 8 is equal to 2 over 7. So we write here 25 to 25 plus 24. So 2b plus c over 8 is 2 over 7 into, so this is 49 over 25. So this cancels out, 7 7 49. So 2b plus c over 8 is basically 14 over 25, right? So 2b plus c is equal to 14 multiplied by 8 over 25, right? So 2b plus c is equal to 8 into 4, 32, 112, right? 4, this is over 25. So 2b plus c is equal to 112 over 25. So we have another simpler expression, 7 and 8. Maybe we can solve them together. We can substitute the value of, for example, c here. From c, from this we can substitute the value of c. Obviously we can have a simpler method to arrive at this partial fraction, but let's solve it anyway. So from this 2b plus c, 2b plus c is equal to 112 over 25. So c is equal to 112 over 25 minus 2b, right? This is our equation number 9. So let us put this here in equation number 7, which is 5b plus 5 into c, right? So 5 into c is 112 over 25 minus 2b, right? So 5b plus 5c, and c is this value 112 over 25 minus 2b, and that is equal to 88 over 5, right? So 5b plus 112 over, this will be 5, right? Minus, this is 10b, then 5 into 2 minus 10b, that is 88 over 5. So that leaves us with minus 5b, right? 5b minus 10b is minus 5b, and that is equal to 88 over 5 minus 12 over 5. So rather we will say that 5b is equal to 1112 over 5 minus 88 over 5. So 5b is equal to 12 into that is 12 minus 8 is 4, and then 10 8 minus 2 plus 24 over 5. So b is equal to 24 over 25. b is equal to 24 over 25. And substituting this value here in 9, we get c is equal to 112 over 25 minus 2 into 24 over 25, right? So c is equal to 112 over 25 minus 48 over 25. So c is equal to, that is 4 and 64 over 25, right? So this is the value for c that we have obtained, right? So the value for a was also minus 24 over 25. A is equal to minus 24 over 25. Yes. So we can express our transfer function. We had this transfer function here. Yes, here a over s plus 3 over 2 plus b s plus c over s square plus 4. So we can substitute the value of b and c here to write it to find out the inverse Laplace transform. So it will help if we first express this c similar to these values here. These are 24 over 25. This is also 24 over 25. So we can write C as C is equal to 64 over 25, that is 8 into 8 over 25, right? And if we want to make it 24, so that is C is equal to 8 over 3 into 24 or 25. So this is the value of C. So now our function was V naught is equal to A over S plus 3 over 2 plus BS plus C over S square plus 4. So let us now substitute the values. So V naught is equal to 24 over 25. A is equal to minus 24 over 25. Minus 24 over 25 divided by S plus 3 over 2. And we have B, which is also 24 over 25 S, and we have C plus 8 over 3 into 24 over 25 divided by S square plus 4. So this is our transfer function, right? So we can take 24 over 25 as common. So V naught is equal to 24 over 25, and we can write it minus 1 over S plus 3 over 2, and this will be plus S plus 8 over 3 S square plus 4, right? So we need to, this is the simple expression. The Laplace transform, inverse Laplace transform is simple for this, right? But for this we need to manipulate it further, right? So this is S square plus 4 term, right? So this can be written as S over S square plus 4 plus 8 over 3, yes. So this is V naught is equal to 24 over 25. This is minus 1 over S plus 3 over 2 and plus S over S square plus 4 plus 8 over 3 over S square plus 4. So now this is also simple. This is the Laplace transform of cos omega t, right? And this can be transformed to a Laplace transform, which is an expression which is a Laplace transform of sine omega t, right? So so this is V naught is equal to 24 over 25. This is minus 1 over S plus 3 over 2 plus S over S square plus 4. And if we consider this omega is equal to 2, yeah, this is square of 2 square. So we can have 2 here plus, and 4 over 3 is multiplied with 2 over S square plus 4. So now if we take the inverse Laplace transform, then V naught t is equal to 24 over 25, and this will give us minus e raised to power minus 3 over 2t, and this is the Laplace transform of cos 2t, right? And this is the Laplace transform of sin 2t, 4 over 3 sin 2t. And we put u of t here to emphasize that this is the response for t greater than or equal to 0, right? So let us take a look back here. So we found out that a is equal to minus 24 over 25, and then we found out that B we already found out is B 24 over 25, C is a 64 over 25. So C is expressed is like this, 24 over 25 into 8 over 3, and we had this Laplace transform here, 4 over S over S plus 3 over 2 into S square plus 4, and this was expressed using this expression for which we found out the expressions, and this was A over S plus 3 over 2, B S plus C over S square over 4, right? And A was found out to be this, and B and C we found out the values, so we substituted the values here. For A, minus 24 over 25 over S plus 3 over 2, then 24 over 25 S. For B, S plus 8 over 3 plus 24 over 25, right? And then after substituting the values, this expression was simple, and this was broken down into two further expressions, S over S square plus 4 plus 8 over 3 over S square plus 4. So that was 4 over 3 into 2 over S square plus 4. So the Laplace transform is now simple. This is 24 over 25 into e raised power minus 3 over 2t and cos 2t sine 2t, cos 2t plus sine 2t, right? So this completes the solution for the given problem.